This is the second video in a series of videos covering linear relationships for New South Wales Mathematics Stage 5.2 course. In this video, I'm going to look at the gradient intercept form of a line and compare it to the general form. We already are familiar with gradient intercept form. That would be y equals mx plus b. As the name suggests, we have the gradient explicitly in our equation and the y-intercept explicitly in our equation. So when I see this equation, the y has a coefficient of 1 in front of it, the x has a coefficient which represents the gradient, and I have a constant term, that's b. But equations don't always come so clearly set out. The general form is written as ax plus by plus c equals 0. And this is a very common way of representing the relationship between x and y. If you notice some of the parts of this, we have two variables, our x and y. Here we have our two variables, x and y. There are no other variables here. Remember that the equation is the relationship between the independent variable and the dependent variable. Y values depend on x. That's the same case here, even though it hasn't been written the same way. And we have three constants in our new equation. A, this is not gradient, because the constant in front of y is not 1. And here's my third one. To convert between these two, it's really more an algebraic exercise rather than a linear relationship exercise. So let's start with the general form and see how we can rewrite this in the form of gradient intercept. So to get to gradient intercept, I need the y variable on its own. So I am going to leave the by, and I'm going to move the ax. Since it's plus ax, it becomes negative ax. I take ax away from both sides, and I take away c from both sides. This is not exactly the same as gradient intercept form, because this b value in front of y might not be 1, it might be some other value. So to eliminate the b from the left hand side, I need to divide both sides by b. b over b gives me my 1y, and I end up with negative a over b x minus c over b. So let's just clarify, let's not get confused with the two b's. This b is specifically the y-intercept. This b was the coefficient of y in my general form. So here the gradient is negative a over b, and my y-intercept is negative c over b. I hope that's clear. Let's do a numeric one as an example, just to clarify. So my first step would be to take the 2x and negative 8 to the other side, or eliminate them by taking them away from both sides. So I end up with 4y equaling, I take away 2x, and because it's minus 8, I add 8. And then I divide by 4. So negative 2 divided by 4 is negative a half, and 8 divided by 4 is 2. So in this case, my gradient is negative a half. My y-intercept occurs at 0, 2. Let's have a look at another example. So in this case, I am actually going to skip some lines, and I'm going to just use my intuition and my knowledge that I've gained from looking at this to work out what gradient and y-intercept is. So gradient, remember gradient was negative of a over b, and my y-intercept was happening at negative c over b. So given that my a is 4, my b is negative 3, and my c is 9, rather than do the rearranging, I can figure out my gradient by substituting the values. Negative 4, because I have this negative up here to carry down, over negative 3, the two negatives will cancel, I get 1 and 1/3, and my y-intercept occurs at x value 0, negative c, that will be negative 9 over b, negative 3, and negative 9 over negative 3 simplifies to just 3. So that's going from general form to gradient intercept form. We are now going to go the other way. So going from y equals mx plus b to the general form. So all I need is all three terms together. So what I am going to do is I'm going to move this y from the left hand side, eliminate it from the left hand side, and all that requires is to take it away from both sides. So I get 0 equals mx minus y plus b. That's all you need to do. It really doesn't matter if you move the mx plus b to the other side or y to the other side, it works out the same way. Now, it's very rare that we would have to do that. It's usually the case that we want to go from the general form to the gradient intercept form. The purpose for that is to be able to identify the gradient and the intercept.